This is video lecture number 3, chapter 14, Solutions. We only have two major concepts left. The one we cover today is called solubility. If you add 36 grams of sodium chloride to 100 grams of water at 25 degrees Celsius, all 36 grams of the salt will dissolve. But if you try to add one more gram of salt, it will not dissolve, no matter how long or how vigorously you stir the solution. This leads us to the term called saturated. A saturated solution contains the maximum amount, I should have written in, of solute, remember that's what is dissolved, for a given amount of solvent at a constant temperature. So think of a sponge. If a sponge is saturated, it's holding all of the water it can hold. If you try to put one more drop of water in that sponge, it is not going to sink into the sponge or be absorbed. That or another drop of water will simply fall out the bottom of the sponge. If the sponge isn't saturated and you add another drop of water, the drop of water will be absorbed by the sponge. And the same thing happens with a solution. If a solution is unsaturated, the solution contains less solute than it can hold at a given or constant temperature. We also have a condition called supersaturated, a solution that contains more solute than it normally can at a given temperature. But supersaturated solutions are very unstable, and we might discuss that more in class. Supersaturated solutions occur when we heat a solution to a higher temperature. We have then cool it down slowly enough so that the solute does not crystallize out. A good example of this is fudge. Fudge is a supersaturated solution of sugar. However, it is very unstable, and I hear it takes a very good hand to actually make fudge right. So if we go to the next page, what we really have to understand is Table G. Table G shows us the relationship in a graph between temperature and a specific amount of water, 100 grams. So the table shows us how much of a particular solute will dissolve at a particular temperature. So the first one I'm going to look at is KClO3. At 20 degrees Celsius, how much KClO3 will dissolve in 100 grams of water? So we find 20 degrees Celsius, we follow it up to the KClO3 line, follow it to the left, and it's approximately 8 degrees. If we were to increase the temperature, 8 grams will dissolve. If we increase the temperature to 40 degrees, and we look, we see KClO3, you can now dissolve about 15 grams of KClO3 in 100 grams of water. If we change the solute, how about, let's look up here, KNO3. How much KNO3 can dissolve in 100 grams of water at 60 degrees Celsius? So at 60 degrees, I follow up to the KNO3 line, follow to the left, and it's approximately 108 grams. If I cool the solution down to 50 degrees, then I see I can only dissolve about 83 or 84 grams of KNO3. So there's much more to this. I will probably cover it in class. So not bad, a 5.5-minute lecture. See you in class.